Well, welcome to the Middlesex Moments radio show. I'm Dr. Anna Wasesha, president of Middlesex Community College, and I'm excited today to have Steve Krevisky back here in my office. I think you have all probably heard Steve on previous programs talking about baseball. But today we're going to produce a program that isn't really evergreen, except I suppose that a year from now it could be aired because it's pi. We're going to be talking about pi, and it's mathematical pi, not apple pie. And pi is sometimes represented as 22/7, sometimes as 3.14. So mathematicians on this campus, and I think on campuses across the country, are celebrating March 14th as Pi Day, and we are going to be doing exactly that here at Middlesex Community College. So I've asked Steve to come onto the program and talk to us about pi, 22/7, 3.14. So do you want to talk about it mathematically first? Because it's really not 3.14. It's a non-repeating decimal that goes out to the end of time. How is that even possible? And what is that? Why is that important?
Well, Anna, thank you for having me on the show again. Pi goes back to ancient cultures. It developed as the ratio of circumference to diameter in a circle. The diameter is the length of the line segment going through the circle, passing through the center, and then the circumference is the distance all the way around, which is sort of like perimeter. So ancient cultures like Greeks and Egyptians knew a lot about pi and math in general, and a lot of the geometry that a lot of you listeners might have learned in school, congruent triangles and things like that. I used to love those proofs, by the way. A lot of that ancient stuff goes back to the Greeks. And so pi was the ratio of circumference to diameter, and it turned out that pi is what's called an irrational number, because as you mentioned, Dana, the decimal pattern, well, actually, there isn't really a pattern, but 3.14159, etc. goes on and on. It doesn't repeat and it doesn't terminate. So such decimal situations are called irrational numbers, and they are real numbers, and they're all on the number line. And so pi shows up in a lot of measurement problems with circles, but it also shows up in some things that happen in calculus. So when you talk about the trig functions like sine, cosine, tangent, pi shows up in that area as well. And also with infinite series like 1 plus a half plus a third plus a fourth. Infinite series, a number of things relate to pi in that area as well.
Tell me more. What is an infinite series?
Well, that means like if you keep adding numbers, let's say like 1 plus a half plus a fourth plus an eighth, which is called a geometric series. Each number is 1/2 times the number that came before it. Mm-hmm. So in calculus we talk about, do such series converge because they approach a limit, or diverge because they go off to infinity. And so pi comes up in some realms of analyzing infinite series because they go on and on. See, if you had something like, let's say, 1 plus a half plus a third plus a fourth where it stops, and by the way, those kinds of fractions with numerator 1 are called unit fractions that the Egyptians knew about. So if it stops at a point, it's finite. If it keeps on going, it's infinite. And so in our basic classes, we talk about rational and irrational numbers, and pi comes up also in formulas for area of a circle and circumference and things of that nature too.
This is great. I was really looking forward to asking you questions because I feel like a math student myself, and I know that you're one of, you're an incredibly popular math instructor. So I'm going to use this half hour to learn some other things too. Like I want to ask about what's the difference between algebra and calculus. We have to take a break, then we're going to come back to mathematics with Steve Krevisky, a professor of mathematics here at Middlesex Community College, and all about pi. And from pi we'll springboard into mathematics in general. So we'll be back in just a moment. Well, welcome back. I'm Anna Wasesha, Middlesex Community College president, and today I'm talking with Steve Krevisky, professor of mathematics here. And what we're gathered here today to talk about is pi, P-I, Greek letter. And there's no, like with mu, we use Greek letters.
Yes.
But then when you're talking about, it's populations and samples, right? So you use mean Tell us about why you use Greek letters to describe some mathematical events, and then you use what? We use Romanized regular letters to describe...
Well, in terms, like in our statistics classes, we distinguish between the mean of a population. Let's say if the population is all Middlesex students, then the mean, let's say if we were talking about the mean age of all Middlesex students, then yes, we'd use the Greek letter mu to describe the mean or the average of all the ages. If it's a sample, which is part of the whole, in particular, we talk about random samples so that all people are equally likely to be chosen, then for that mean, for a sample, we write x with a bar above it, and we call that x bar. And we often talk about what can you infer about a population from a random sample, which is inferential statistics.
Do you remember why they decided that they would attribute the Greek letter to the population and just x to a sample? I mean,
I'd have to research why that's the case, but we also use Greek letters in statistics. We use the symbol, the Greek letter alpha, for what's called the level of significance in a hypothesis test. So it shows up in that arena. And then with trig functions, we use the angle theta, like when we talk about sine theta, cosine theta, tangent theta rather. So Greek letters show up in a number of arenas in math.
It's really true. I remember when my daughter first got into calculus, she was frustrated because she didn't know what they meant. Yeah, it's a vocabulary, the vocabulary of mathematics.
Very much.
So I've got so many questions. So let's go back to number line. That's a really intriguing concept to me. So what is a number line, just to begin? How would you define it?
Well, on the number line, we have one way to look at it is the number line consists of all the real numbers. So
what's a real and a non-real number?
Okay, well, yeah, because there are numbers that are not real. They're called imaginary and complex numbers because when you talk about square roots, let's say the square root of 4 is 2 because 2 squared is 4. Or in baseball terms, the square root of 4 Lou Gehrig is 2 Derek Jeter. I use that in my classes. So all the numbers on the number line consist of the rational numbers, which are the fractions, and then the irrational numbers like pi or e or other such numbers. One way that we talk about that in, let's say, our basic algebra classes is that if you start with 0, then you have positive numbers to the right and negative numbers to the left. And you build up the number system when you talk about natural numbers, then whole numbers, then integers. So all the numbers on the number line are the real numbers. And then there's all sorts of analysis you can look at. Sometimes we're interested in parts of the number line to sort of relate it to statistics. If you think of all the numbers on the number line, the real numbers as your population, then maybe if you're only interested in the numbers between 0 and 1, which would be the unit interval, that would be like a sample that's part of the whole. And you mentioned calculus and your daughter. When we talk about the notion of function to each x there's only one y, and we talk about graphs of functions, then we're interested sometimes in what's the domain, the values of x for which the graph is defined. And sometimes we're interested in particular intervals where we could talk about, does the graph reach a high point, a maximum, or a low point, a minimum? So sometimes we focus on part of the number line because we're interested in what's the graph of a function doing on a certain interval that's part of the number line.
In lay terms, what's the difference between, what use is calculus? Why would somebody want to know about calculus and know how to do calculus?
Well, calculus in summary talks about rates of change of different types of quantities.
So it's numbers in motion.
Yes, that's a good way to look at it.
Okay.
So in other words, as x changes, how does y change? So let's say, for instance, if you're going on a trip, let's say you drive 150 miles over 3 hours, then your average speed is your distance 150 divided by your time 3, so you average 50 miles an hour. However, at any given instant, you might have been going faster or slower. You stop to take breaks. So at certain periods of time, at a particular instance, maybe you're going 60 miles an hour, maybe you're going 40 miles an hour. So that notion of what would be your velocity at an instant as opposed to your average velocity are things that can be calculated if you have an equation that describes your motion. And also we talk a lot about what's your maximum, what's your minimum. So you get into problems like if someone's, let's say, building a yard and they want to fence off their yard, then what would be the maximum area that a fence of a given perimeter could enclose? So calculus enables you to solve some of those kinds of questions.
That's a real specific and very practical application of calculus.
I would think so.
Yeah.
Or another way to put it, if you're painting your house, how many gallons of paint would you need so that you minimize your costs?
Sure.
Things like that.
Sure. Boy, in industrial agriculture, there are computers in all the tractors, and they actually calculate how much fertilizer you need based on the makeup of the soil at any given point in the field. So they get the most amount of growth from your seeds with the least amount of application, because that's where the costs are. So you have students in calculus here at the college.
Yes, we offer calculus every year, usually Calc 1 in the fall, Calc 2 in the spring. The last few years we have been able to offer Calculus 1 in the spring, the off semester, and if all goes well we'll offer Calculus 3 in the fall, and we've wanted to offer more advanced classes so that while we're preparing to deal with the aftermath of the Public Act 1240 about the remedial developmental level, we don't want to forget about our students who can do that kind of advanced math. And with the math contest coming up on Thursday, April 10th, then those are the students whom we're going to want to do the system math contest and we give prizes to the winners.
And every year we have some winners, right?
Yes, we've had full rooms of students the last few years. We probably have the highest level of participation in the system, and some of the questions, most of which I write, could involve maybe something with pi and geometry or quadratic equations, or when we talked about statistics earlier, there could be problems about find the mean of a group of numbers. I always put in a baseball question. I'm known for that.
Yeah, I'm not surprised. Not surprised at all. Can you tell us what happens to a student who goes all the way through the calculus sequence? I mean, do they generally transfer to four-year institutions, or what kinds of careers? Do you have stories about where they might have ended up after having gone through Middlesex's math program?
A number of students from my calculus class last year, which was a very strong group, some of them have gone on to Central, and I've been trying to keep things together with those who are still here with our math club and honor society, but a lot of them did go to Central or Southern. And also, since this is time to write student recommendations, one of my students from last year's calc class is transferring, so this is the time where we write letters, for people like that who are going somewhere else. So I was fortunate to have a very strong group last year, and hopefully Pam and Mary have the same this year.
That sounds great. Well, we're going to have to take a break in just a moment, and I don't want to minimize it. I think that's fantastic. I mean, I think in general that students either aren't interested in mathematics very much, or maybe don't do as well, and in fact, it opens all kinds of career doors, not only in industry and business, but also in education and in healthcare. Probably, in fact, I would say about my own job, it's impossible to do my job without at least a basic understanding of mathematics and algebra and a little tiny bit of calculus. Although I never took calculus.
Not yet.
Not yet. Thank you. What a wonderful idea. Okay, well, we're going to take a break, and I'm smiling broadly about the idea that I might someday take a calculus course.
Why not?
I could do it here.
That's right.
And when we get back, we're going to talk about Pi Day 3.14. Well, welcome back to the Middlesex Moments radio show right here on WLIS WMRD. I'm talking today with Steve Krevisky, who teaches mathematics here at the college, and the reason we got together this week is not to talk about baseball, which we will talk about in future show, but to talk about pi, P-I, and 3.14 and 22 over 7, and how mathematicians across the country get their students excited about pi by celebrating Pi Day on 3.14 March 14th. But why don't you tell us what you're doing here at Middlesex? Because I know you're going to be both in Meriden and here in Middletown, and on 2 different days, and neither one of which are 3.14 actually. 3.12, 3.13. So tell me what you've got planned.
Oh, good. Well, the math department has been active in a number of realms, and so we've had a tradition here of observing Pi Day. Now, since Friday is March 14th, the actual Pi Day 3.14, since there aren't many classes and it's the start of spring break, then we decided to move it up and do it a day early. So on the main campus, Thursday, March 13th, from 3 to 4, Student Lounge, we're going to observe Pi Day. So people are going to bring pies, hopefully with a Pi logo on top. And I'm going to sing a Pi Day song with Dean Minkler on the piano. It's a math version of the song from the old play, Damn Yankees, You Gotta Have Heart. So the song is You Gotta Have Pie. And I'm hoping that people in the audience will help me sing along. And also, since French is my second language, I'm going to do the chorus at the end in French.
I didn't know French was your second language.
Oui, c'est ma deuxième langue.
That's fantastic.
So that's what we're going to do. And hopefully members of the math club will be present. Faculty, staff, management, students are all invited. And it's something that a lot of colleges do across the country and hopefully around the world to commemorate this special day. So we'll have pies. Hopefully, maybe we'll have like a guess the number of jelly beans in a circular canister if we can do that. We're also going to do this on the Meriden campus, which is an important part of what we do, and I teach over there on Mondays and Wednesdays. So Wednesday, March 12th, from at 12:30 in the community room in Meriden, we're also going to do a Pi Day commemoration there. So therefore, Wednesday at Meriden, Thursday on the main campus, we'll observe Pi Day, and we invite everyone to join us.
So we have a math club, don't we?
Yes, we do, and some of those people are in the Math Honor Society.
Which is Mu Alpha Theta.
That's right, more Greek letters per where this started. So hopefully some of those people will also be involved in this. I've had contact with them, and last year, we were able to induct some people into that honor society. So this year, things are more scattered, but we hope that people will still be involved from that math club, and so that gives people a chance to get together and observe something that's special to the math community. And next year, and I think you and I talked about this, March 14th, 2015. That'll be special because pi starts 3.1415 in its decimal expansion, and that's what next year is going to be, 3.1415. So maybe we'll be able to do something extra special for that.
That's fantastic. I have to say, I did a little tiny bit of research about this morning, and there is some student, and I'm sure this is true around the world, who memorized something like 60,000 of the decimals. So I was looking at this long string of decimals, and there's no pattern. Once you get past 3.1415, and you know many of those decimals, but there's no real pattern. Is that the definition of randomness? I mean, because that's actually not random. That's mathematical. It's true that is the relationship between the diameter and the circumference. So what is the difference between that string of numbers, which is true, an accurate depiction of a relationship, with randomness? Because it sure looks random to me.
Well, good question. Like in our stat classes where we talk about random, that if you're picking people out, let's say, all people have to be equally likely to be chosen, and a sample has to be representative of the population. So if you were picking random numbers, let's say on a random number generator, or in stat books there's a table of random numbers, the numbers that get picked should not have a pattern. So when I ask my students related to that, since I have a project requirement, if you talk to people in the student lounge about their favorite pizza, and if you talk to every 10th person, I want them to understand that that's not random because there's a pattern. So you can generate random numbers for a number of purposes. So if the college were doing a study of, let's say, how far students drive to get here, and you'd want to pick out a random sample of students, then the numbers generated, if you listed all students alphabetically from 1 to almost 3,000, then let's say you had a random sample of 200, then the numbers that you pick for the students should not be in a pattern. Now, the expansion for pi, excuse me, can be generated mathematically through infinite series or other means. Now, so that's a specific representation. It might look random. That's an interesting question in terms of, is it really random? Because it follows the mathematical logic of how you would derive things. Similarly, there's another famous irrational number, e, that occurs in logarithms, and when you talk about exponential growth and decay, e is 2.718, and it shows up in problems like half-lives of radioactive substances and things like that. So e can be derived through what we call the notion of limit in calculus. As x approaches something, what does y approach? So there are like mathematical derivations for why the digits turn out the way they do.
Do you think that it's hard? I was, as we were talking, I was thinking about math anxiety, which people don't talk about very much anymore. But it's still a little hard to picture in your mind's eye what you just said, which is when x approaches a certain number, what happens to y? So how do you have, like, as a teacher, how do you help students actually see that, see why what that means, what the importance of that is?
If you had an equation, let's say something like y equals 1 over x, then one way to help you see what happens as it connects to a graph, you could make a table where one column has x and the other column has y. And if you pick numbers for x, let's say x could be 2, 5, 10, 20, 30, then you can calculate 1 over that. So let's say 1/2, 1/5, 1/10, and you would want students to see, what would be the pattern that as x gets bigger, you'd want them to see that y gets smaller, that it's an inverse relationship. So via graphs and charts and things that we do in our classes, then you give students a visual representation of what's going on so that they can plot it on a graph and see what it looks like. And in relation to your asking about the relevance of math, if you're a consumer and you have to make a decision, let's say, about which cell phone plan is better for you because there's fixed costs and variable costs, or if you're going to buy a car, if you're going to go on a trip somewhere, and what's the best way to organize your trip. There's all sorts of ways that math can come up in ways that people might not realize.
You're a world traveler, so you probably apply your mathematical skills all the time.
Well, I'm a good planner. If all goes well, I'm going to Africa this summer.
That's right.
So I've already started my planning in conjunction with a colleague with whom we hope to co-present at this conference in Mozambique. And then also I'll be working with EJ, our early childhood person, to do math workshops in her native Nigeria. So I'm looking forward to going, and there's some other sites I want to see. So that's a lot of planning, and I'm one who likes to look at maps, and I'll spend months planning because a trip like that isn't something you can do at the last minute. So, to our listeners out there, if you were planning a trip somewhere, you might want to think about how can you maximize your time and minimize your distance.
Yeah, that's right.
Things like that.
That's right. And if you're thinking about taking a math course, you might think about coming to Middlesex Community College. Sign up for one that Steve Krevisky is teaching. I really appreciate your coming here today. I'm excited about Pi Day. I will be there. I promise to kind of try to sing. And you got to have heart. You got to have pie.
And I hope our listeners will come join us
Sure. Everybody is welcome at Middlesex Community College. So that's in Meriden. It's Wednesday, March 12th from 12:30 to 1:30, and in Middletown, Thursday, March 13th, 3 to 4. Steve, thanks so much for joining me here today on Middlesex Moments. And to everyone in our listening audience, I hope you have the best day ever, and think about pi on 3.14 this Friday.